see, for example, assume 10 say let us assume 1000 values are mapping to the same index 3. I want to search for the last value. So say 1000, I want to search for the 1000th value. If it is if only one value is stored in each index, searching will be easier. Here, since 1000 values are mapped to the same index, searching time is more. So this is the major drawback with separate chaining. So to overcome this drawback, we go for quadratic probing technique. So under quadratic probing, we have seen linear probing. So as the name indicates, by what is meant by linear? Single. So the values are incremented in singles. So x, if x is a given data item, and when collision occurs, every time collision occurs, the given data item will be incremented by 1. So again, if you are when you are incrementing by 1, if again collision occurs, again you will increment the data item by 2. When you are incrementing by 2, if again collision occurs, you will increment by 3. So this continues until a suitable index is found. So in the previous session, we have discussed about what hashing is about and why do we go for hashing. We have seen the scenarios where collision occurs, and Santosh and Karthikeyan has discussed about two collision resolution techniques. One is separate chaining and other one is linear probing, which comes under quadratic probing. So the major drawback of separate chaining is search time will be more when more values are mapped to the same index. So to overcome that drawback, we go for quadratic probing. So it is not quadratic probing, it is open addressing. So under open addressing, we have seen what is linear probing. So what is linear probing? Every time collision occurs, the the data will be incremented by 1. So that is linear probing. So now we will discuss about what is
அந்த மாதிரி செப்பரேட் செயினிங்கெல்லாம் நம்ம யூஸ் பண்ணி கண்டுபிடிச்சோம். இப்போ குவாட்ராட்டிக்கில் வந்து நம்ம எடுக்கிற வேல்யூ நம்ம டேபிள் சைஸில் இன்சர்ட் பண்ண முடியலன்னா, அந்த டேபிள் சைஸோட வேல்யூவோட நம்ம வந்து 1 ஸ்கொயர் பண்ணோம்னா நமக்கு அந்த வேல்யூ வரும். சப்போஸ் நமக்கு அந்த வேல்யூ வரும். சப்போஸ் நமக்கு அந்த வேல்யூ வந்து இங்கே இருக்கிற வந்து டேபிள் சைஸ் ஃபுல்லாக இருந்துச்சுன்னா, நம்ம இன்னொரு ஸ்கொயர் வேல்யூ எடுத்து அந்த ஸ்கொயர் வேல்யூ இன்சர்ட் பண்ணுவோம்.
So linear probing, every time collision occurs, we will increment the data by 1. So in case of quadratic probing, every time collision occurs, we will increment data by 1 square, 2 square and so on. So that is quadratic. As the name indicates, quadratic means square. So we will increment the data by square values. So next explain about double hashing.
So now let's see about double hashing. Double hashing means we will be using two functions. For there is a formula for that. So first one is h1 h plus 1 into h2 h modulus of table
into
size
into I okay, whole modulo table size.
So for finding the h1 value, we will be taking the modulus 10 for the given table. So for first value, let's see how we will be applying the value. So there is a value 4371. So there is no collision, the table is completely free. So we are inserting the value at the first column as the modulus of 10 is 1. So we are inserting the 341 at the first column. Next we are seeing the second value. The second value is 1323. Its modulus of 10 is 3. And 3 index also there is no value, so we'll be able to insert a value there. So third value is 6173 and the modulus of this value is 3. But let's see, like here we had already inserted value in the index value, so we are using this formula. So for finding h1, I am taking the modulus of 10 for the given value. The given value is 6173. Its modulus of 10 is 3. For finding the h2, I am taking the same value but with the modulus of 7. While taking the modulus for the given value, we will be getting the modulus as 6. So now let's apply on the formula. h1, which is 3 plus 1 into h2. h2 value will be 7 minus 6. Because second function will be 7 minus modulus of 7. So we are minusing the value and we are getting 4 into 1. While seeing the fourth column, fourth index is free, so we will be able to insert the value here. Likewise, we will be able to insert all values, but while inserting the 1989, when the I value is even till 4, we will not be able to insert the value. So at that time we will be using rehashing. Rehashing is simple term where we will be increasing the table size. If we increase the table size, what we'll be doing now, we will be uh, multiplying the table size into 2. Here the table size is 10, so we are multiplying the table size into 2. So the answer will be 20. We will be taking the rehashing as a prime number. So what is it? So 23 is the nearest prime number of 20. So while by using the 23 as the table size, we will be able to insert all values.
So as name indicates, by means of double hashing, we will be doing hashing twice. So here we use two hash function. So when collision occurs for the first hash function, we will be using another hash function to calculate a value. We will multiply these two hash values and we will again hash it using the given table size. So here initial hash function is given as x modulo 10. So for that we will calculate one value, and if collision occurs we opt another hash function which is 7 minus x modulo 7, and we will calculate a value for that as well. We will multiply these two hash values and again you will apply the initial hash function which is x modulo 10. So you will hash this as the data modulo 10. So for the final value you will store the data. For the final key value you will store the data. So when you are applying double hashing for the given set of values, when you try to insert 1989, you cannot insert 1989 because every time you apply double hashing, the index repeats the same. So the index that you are obtaining is the same index you have obtained in the previous hash values. So you cannot store 1989. In such case we go for a technique called as rehashing. So as the name indicates, what is meant by rehashing?
Increasing
You are
the
doing
table.
hashing again. So it is rehashing. So when you want to do rehashing, you will change the table size. So the how do you will change the table size is that you will double the given table size. So initial table size given is 10. So when you double it, the value will be 20. But when you are doubling the table size, you have to ensure that table size is a prime number. So here 20 is not a prime number, so you have to choose the next nearest prime. So when if you choose the next number 21, it is odd number, it is not prime. 22 again it is not a prime. So next number is 23, it is a prime number. So the nearest prime value is 23. So that nearest prime value will be chosen as the table size, and same hash function x modulo 23. For that you will apply hashing and you will store the values in the index. So that is rehashing. Clear?